access point and they have lots of devices?
Yes, because my core background is actually indoor localization. If you wanted to, this is a very interesting question. I was actually asked by some of my dorm operators, can you tell me who's in what room? I didn't want to get involved in that because we actually can. Based on the location, from seeing from multiple access points, I can actually locate where the devices are very accurately. But I didn't want to get into
Well, what if their laptop is in the study room and their phone is near the bed?
We kind of ignore laptops. In many cases, laptops are our least reliable device. We look at phones, we look at watches, because you will never leave your phone behind. Students never leave their phones behind.
Thank you. You have a quick question, or can you reserve that for later? Okay, great. All right. Do you need this, or you want to speak there? Okay. All right, the next speaker will talk about sensing synchrony in performance. Oh, you got it? Can someone actually help, student volunteer, or is it plugged? Okay, great. So Yanke and the team from Jamie Ward's lab is here to present their talk on interpersonal synchrony.
Hello everyone, my name is Yanke-san, and today I would like to introduce our work on using variable sensors to measure interpersonal synchrony in actors and audience members during a live theater performance. In our work, we show that using variable accelerometers can be used to detect the interpersonal synchrony between the actors and audience in a theater performance. And this approach can form a powerful tool for doing real-world research on the social interactions. So to achieve these aims, our research unfolds in several key stages, which are listed in the slides here. Now let's continue with the detailed introductions of each step. Our first act is the process of data collection, and the data from this work was collected during a live event consisting of actors performing a piece of theater, referred to here as the act, and scientists giving talks, and some interactive games that involving the actors and audience participants on stage. The details procedures of the performance is listed here in this table. There are 22 participants recruited in this study, which includes 6 actors from the Flute Theatre company and 22 audience members who bought the tickets to watch the show. The audience members can further divide it into 2 groups. There are 5 audience participants who went on the stage and played the games with the actors during the game sections, and remaining 17 audience spectators who remained seated throughout the performance. We equip all the actors and audience with head-worn variable sensors and capturing their every moves during the performance with the 3-axis acceleration. And after the performance, we asked every participant 12 closed-ended questions about their engagement with the performance. And each question was rated on 1 to 5 Likert scale. Following data collection, the next step is the synchronization and pre-processing. It is critical to ensure that the individual recorded signals of multiple subjects are accurately synchronized in time. So the synchronization actions, that is shaking the sensors together, were performed several times during the performance to generate easily identifiable pattern events in every sensor. So then we can use the interpolation techniques to automatically correct the time errors between all the sensors. Then the synchronized data is filtered and calculated magnitude for further analysis. This figure here shows the synchronized data between the 27 subjects for the performance. Now let's step into the spotlight with the data analysis. Here shows then simple examples of two time series data. The first step is we apply the continuous wavelet transform on these two signals to obtain the wavelet coefficients, with the x-axis represent the time and the y-axis represent the periods of activities or the frequency of activities. And then the next step is we combine the outputs together to obtain a common time spectral response. There are two ways to combine them. The first one is the cross-wavelet transform, which reviews the areas with high common power. And the second method is the Wavelet Coherence Transform, which highlights the common frequency regardless of the power. And then we can calculate the average power across a specific frequency range that we want to focus on for a different application. Now I would like to introduce the findings that emerged from our analysis. In this figure here, it shows the interaction matrices between different sections of the performance. The interaction matrices can clearly show the pairwise interactions and spot interaction pairs clearly. For example, you can see the actors are highly synchronized in the act sections and also in the game sections. In addition, the actors and participants are tightly coupled there in the game sections because the participants went on the stage and interact with the actors. Another way to visualize the interpersonal synchrony is to plot the power over time. Here it shows in short period examples that between the audience over the act period. It's obvious to see the variation of the power over the performance. And you can see there's an increase of the power during some intense emotional periods. For example, a prominent peak is observed when the audience laughs together, and also another peak is reached when one of the actors talks to the audience. Finally, we want to find the link between the variable data analysis and the self-report scores. So we did the Pearson correlation between all audience and actors synchrony with audience spectators survey response for the actors' performance. And the significant correlations were found between the power and two questionnaire atoms, which are the emotional response and the empowered. And this is consistent with the idea that watching a theatrical performance can be an emotionally moving experience where you are drawn into the world of the performance and interact with them. In conclusions, data analysis from variable accelerometers, audio-visual labeling from the video, and the self-reporting of participants were combined to investigate the synchrony between actors and audience from a live theater performance. And the cross-wavelet transform and wavelet coherence transform analysis enables the moments of synchrony at different frequencies to be analyzed. And finally, the levels of interaction are proved to have the link with the survey results from the participants. Thank you. That's all of my presentation. And also thank you for the team who created and run this project.
Brilliant. You finished just under 7 minutes, so that's a great one. So any quick question?
Thank you so much. I think it is a cool work on a very interesting field. I wonder if you have insights into, because you use accelerometer as your sensor, which is more interpretable than many of the other sensors. And then what are like their behavior traits that are indicators of synchrony if you did your analysis based on accelerometer of their head movement? So like if you translate into like human understandable way of saying this, right? What are happening to their head's motion that are indicators of like synchrony? Like what's like the behavioral?
For example, maybe when they're laughed together, they will have tiny movements together, and also like when the actors talk to the audience, like they will have some tiny movements that maybe it's not easier to observe by eyes, but it can capture by the wearable senses.
Yeah, that's my question.
Thank you. All right. So the next speaker will be Luke from LMU, who works under supervision of Albert Smith and working on engagement in communication. And I'm actually wondering, you know, perhaps it's a new discrete senses.
Okay, yeah, so I'm Luke Halib.